Hello and welcome to all. I would like to welcome you all in our class where today we are going to discuss about polynomials and especially in case of polynomials. Today we'll be focusing on how we can use synthetic division method while we are dividing polynomials. So we know that in case of polynomials division, there are normally two very much useful methods. One is synthetic division method and another one is normal division method. So today we are going to just focus ourselves on synthetic division method. So let's get started. Now before we go directly into the example part or division part, first of all we should understand or we should get the idea of divisors different forms. We know that in case of polynomials and in case of division while using synthetic division method, the degree of the divisors must be 1. In case of synthetic division method, if degrees are except 1, then synthetic division method cannot be used. So we have to keeping in our mind one thing, that x minus a is considered as the standard form of the divisor in case of synthetic division method. So now, while we are doing calculation or while we are doing various division of the polynomials, we'll find the different forms of the divisor even though they have the degree 1. So here we are going to talk first of all about those different form of the divisors having degree 1 and how it can be converted in standard form so that the synthetic division method can be processed ahead easily. So the first form we can see here that it is x minus a x plus a form. This x plus a form is one of the divisors form. For example, I would like to give you one example which is very much similar with the form x plus a. For example, if we have divisor as a x plus 3, now this x plus 3 is very much similar with the divisor form x plus a. So if we have divisor x plus 3, then of course we have to convert this divisor x plus 3 in the standard form. So for that, what we are going to do is we are going to write first x as it is, and we are going to change this plus into minus. So for that, we are going to write 1 minus outside, and within the bracket we are going to write minus 3. Now we know that when we simplify x minus minus 3, we are going to get the same divisor x plus 3. So in this way, we can change our divisor x plus 3 or x plus a in standard form. So in this particular example, the value of a will be, the constant a will be minus 3. Now let's go to the next form. The next form is cx minus d form. And to clarify it further, I would like to give you one example. Suppose if we have a divisor 2x minus 5. Now let's look at this divisor 2x minus 5. This seems like cx minus d form. So according to our discussion ahead, before, we discussed that our divisors should always be in the standard form. So as you can see here in standard form, the coefficient of x is 1. So due to that reason, our coefficient of this x in case of 2x minus 5 also should be converted into 1. So for that, what we are going to do is we are going to take out 2 common. So when we take out 2 common from 2x minus 5, there will be x at first and minus will remains the same, but there is no 2 in 5. So to make it mathematically balanced, we are going to write 5 by 2. So in this way, we can convert or we can express our divisor 2x minus 5 in the form of x minus a form, where the value of a will be 5 by 2. Now we know that when we simplify this 2 bracket x minus 5 by 2, then again we are going to get our original divisor, that is 2x minus 5. So in this way, if the divisor is in the form of cx minus d, we can convert it easily into standard form x minus a. Now let's go to our third divisor form, that is cx plus d form. This form is only differ by sign than the form in case of second form, cx minus d. So I would like to clarify this one with one example. Suppose if our divisor is in the form of 2x, 3x plus 2, for example. Now it is very much similar with cx plus d. So two things we have to do here. The first thing is we have to make the coefficient of x as 1. And the second thing is we have to bring minus in between this 3x and 2. So first of all, let's make the coefficient of x as 1. So for that, as we did in the second example, we'll take out 3 common. So when we take out 3 common, inside the bracket there will be x plus 2 by 3. So our first task has finished. Now the second thing that we have to do here is there should be minus sign in between x and 2 by 3. So for that, as we did in our first form, example 1, so we'll do the same thing. So we'll write 3 here. So I would like to use curly bracket, and x is already there. So first minus outside, and inside the small bracket, I'm going to write minus 2 by 3. And small bracket close and curly bracket also close. So in this way, here also our divisor has converted in the form of x minus a, where the value of a is minus 2 by 3. So in this way, we can express any divisor which is in the form of cx plus d in our standard form. Now, let's see one more form, that is d minus cx. Now, in this particular example, we need to understand some of the things that in this d minus cx form also, I would like to give you one example so that it will be more clear. For example, if we have divisor 2 minus 5x, for example, our divisor is this. It is not actually a very much difficult one. First of all, we'll just rearrange the term. So when we rearrange the term, then minus 5x will be at first, and after that plus 2 will be there. So as we are going to make first of all the coefficient of x as 1, so let's take out minus 5 common. So once we take out minus 5 common, then within the bracket there will be x, and the minus plus would be minus, and simply there will be 2 by 5. So now it can easily be seen as the form uh, like x minus a, where the value of a will be simply 2 by 5. So these are the various forms that we need to understand while we are using synthetic division method. And as I discussed earlier, in all the divisors form, whatever the divisors form that we have seen here, they all have degree 1, degree 1, degree 1, and degree 1. So it is very crucial understanding that synthetic division method is applicable only when the divisor's degree is 1. In other case, we cannot use synthetic division method. Whatever the degrees of the dividend polynomial, but divisors should be of degree 1. So now after being clear about all these different forms of the divisor, now let's talk about examples. Now let's talk about examples for each type of the divisors so that the idea will be more clear. And even the synthetic division method also will be will be able to understood very clearly. Now let's talk about our first example, that is 2x. Here the divisor is 2x minus x minus 2, which is just like our standard form x minus a. So before we go into synthetic division method, let's look at our dividend polynomial and divisor first. As we know that divisor is already in the form of x minus a, so there is no problem. Or if there is problem also, we know how to convert them also, as we recently talked earlier. Now, look at this dividend polynomial. While we are using synthetic division method, we have to understand that first of all, it should be written in descending power of x. So as you can see, it is already written in descending power of x. Now the second thing that we have to understand is all the variables powers should be written there. That means this dividend polynomial is of degree 3, so x cubed term is there, and x square is there, and constant term is there. But x containing term is missing there. Okay, what I mean is x cube term is there, x square is there, but x is missing there. That means power 1 variables power 1 containing term is missing. That is, x is missing there. So due to that reason, for using synthetic division method, we have to bring that term also. But we know that by just by writing is not enough, or we are not allowed it to write just by writing simply plus x. So mathematically we are going to write one thing, that to regain or to put the value of x, or to put the term x, we are going to write its coefficient 0. So what I mean is, now here the polynomial px is going to be written like 3x cubed as it is minus 15x squared, that also as it is, plus 0 into x. We know that 0 into x would be 0, which will be easily removed, and again we are going to get the same our polynomial px plus 7 as it is there. So in this way, our coefficients are 3, minus 15, 0, and 7 of polynomial px. Now our divisor dx is already in the form of x minus a form, so that we can easily write the value of a is 2. While using synthetic division method, there is one kind of method that we are going to discuss here. First of all, we are going to draw a box here, as you can see on your screen. And within the box, at the top part, we are going to write all the coefficient of polynomial px like this. So, as we discussed earlier, the coefficients are 3, minus 15, 0, and 7. They all are kept here. Now, outside the box, we are going to write the value of a, that is 2, like this. And after that, we are going to drop the first coefficient 3 down, that is 3 outside. And after doing this, now we are going to multiply this 2 and 3. So when we multiply 2 and 3, obviously it will be 6. And that 6 we are going to keep below minus 15, like this. So now it's time to simplify minus 15 and plus 6. So when we simplify minus 15 and plus 6, we are going to get as minus 9 value. So after this, we are going to repeat the same multiplication process. Now this minus 9 is going to again multiply with 2. So 2 times minus 9 will be minus 18, and that minus 18 we are going to keep below 0. Let's simplify 0 and plus 8, minus 18. When we simplify this, we are going to get minus 18. And again, and finally, again, let's multiply 2 and minus 18. So when we multiply 2 and minus 18, it will be minus 36. And that is going to be written below 7. Eventually, when we simplify plus 7 minus 36, the answer would be minus 29, which we are going to put inside this box. Now, everyone, the term 3, minus 9, and minus 18, they will be the coefficient of our quotient, whereas minus 29 will be remain as remainder value. Everyone, let's be clear. So, our quotient will be, as we have seen here, that our dividend polynomial has degree 3 and divisor's degree is 1. So, when this polynomial, dividend polynomial is divided by our divisor dx, then degree 3 of the polynomial will be converted, will be decreased by 1, and that will be the degree of quotient. What I mean is, when polynomial, dividend polynomial degree 3 is divided by divisor of degree 1, then the quotient degree will be 2. So in this way, what we are going to write is qx equals to 3, first term is 3 here, 3 times x square, as we discussed earlier, minus 9 times x. We are gradually writing the descending power of x. So first of all x square, then x, and minus 18. No need to write x to the power of 0. So when we simplify this, the quotient qx will be 3x squared minus 9x minus 18. And the value of remainder will be minus 29. So in this way, we can find quotient and remainder when the divisor is in the form of x minus a. And let's be clear once again, I would like to repeat once again that here the dividend polynomial is of degree 3 and divisor's degree is 1. So when divisor divides this dividend polynomial, then the degree of the quotient will be 1 less than the dividend polynomial, and that will be square. So now let's go to the next form example for the next form of the divisor. So here this time we have divisor. Divisor is y plus 2. This is similar like x plus a form. Okay, but as you can see here, the this dividend polynomial and divisor, it is in the variable y. So our py, our polynomial py will be 2y cubed plus 4x squared plus 3y plus 11. As you can see here that none of the power of x is missing there, starting from y cube. So we have written as it is. And look at this divisor y plus 2. This is similar like x plus a, but we know that always the divisor should be expressed in standard form. So while converting it into standard form, we have to write minus at in between y and plus 2. So y and 2. So what we are going to do is we are going to write y minus and yes, within the bracket minus 2. So in this way, we have the value of a will be minus 2. So you can see the same thing that we have done here. And we have got also the value of a as a minus 2. When we compare this y minus minus 2 with our standard form x minus a, or y minus a also can be said because this time we have variable y. So when we compare, then we get the value of a as a minus 2. Now, using synthetic division method, now we are somehow clear from our first example also. We are going to make our first box, and after that we are going to write all the coefficient of our polynomial py 2, 4, 3, 11. This time we have all the coefficients are in positive sign, and outside the box we are going to write minus 2. So let's repeat the same step. First of all, this 2 will comes down, first coefficients will come down, and after that we are going to multiply minus 2 and 2. So when we multiply minus 2 and 2, it will be minus 4. That minus 4 is going to be written below 4. When we simplify plus 4 and minus 4, the value will be 0, which we are going to write down of this minus 4. And similarly, we'll do the multiplication process. Minus 2 times 0 will be 0. That 0 will be is going to be written in below 3. So 3, 0. Plus 3, 0. When we simplify, we'll get the value 0. Now the last multiplication, when again we are going to multiply minus 2 and 3, we are going to get minus 6, which is going to be written below 11. So when we simplify plus 11 and minus 6, the value will be 5. Now let's write quotient qi and remainder r. So we know that the terms which are outside the box, that is 2, 0 and 3, they will be the coefficient of our quotient, and the term which is inside this box, that will be the value of remainder. So now here we can easily say that our qx value will be, since the degree of the dividend polynomial is 3 and divisor's degree is 1 always, so quotient qx will be of degree 2. So that means qy will be equals to 2 into y square plus 0 into y plus 3. Yes, very good. I think you have also come up with the same answer. And when we simplify this, we got 2y squared plus 3 as a quotient, whereas the remainder value is 5. So this is our second divisor's form example, which is x plus a. Now let's go to the next example, example number 3. In this example, we have divisor is in the form of a cx minus d. So we know that if the divisor is in the form of cx minus d, then we have again need to do the same thing, need to convert it into standard form. So first of all, we'll have 2 common. So when we have 2 common, then inside the bracket there will be x minus 3 by 2. So which is very much similar like our standard form x minus a. So easily from here we can get the value of a as a 3 by 2. And in case of dividend polynomial, as none of the power of x is missing there, so we can easily write our divisor, our polynomial px as it is, and our divisor dx would be changed as we discussed earlier also. So yes, the value of a will be 3 by 2. Now using synthetic division method, so inside the box, first of all, we'll list out all the coefficient of polynomial px, and outside we are going to write the value of a as a 3 by 2. So first, this first coefficient 2 will come down. So when 3 by 2 and 2 multiply, then the value will be 3, and that 3 is going to be written below minus 9. So when we simplify minus 9 and plus 3, the value will be minus 6. And after that, again we'll do the multiplication of this minus 6 and 3 by 2. When we do so, we are going to get minus 9, and that minus 9 is going to be written below 5. After that, when we simplify plus 5 and minus 9, the value will be minus 4. And eventually, when we multiply minus 4 and 3 by 2, the value will be minus 6, which is going to be written below minus 7. So finally, when we simplify minus 7 and minus 6, the value will be minus 13, which we have kept inside the box. Now it's time to write our quotient qx and remainder r. It is very clear that remainder r is minus 13, but while we are discussing about our quotient qx, it is very essential and crucial to understand one thing. Like we discussed in example A and B, we can easily say that our quotient is 2 into x squared minus 6 into x minus 4. We may think that our quotient will be like this. But very important thing that we have to understand that in case of dx, while we are changing our dx, which is 2x minus 3 in standard form, you can see here that we have taken out this 2 common. Right now in this particular example, we have taken out 2 common. So that 2 should be retrieved. That 2 should be useful in some cases. So what we are going to do is, while we are finding qx, this whatever the number that we have taken out common, that number should divide our quotient qx, and that will be our actual value of quotient. Okay, suppose if we have taken out 3 common, then our qx should be divided by 3, 4 common divided by 4, minus 2 common divided by minus 2, and so on. And that will be actually the value of quotient qx if we have taken out any number common. So by taking same idea, now our quotient will be qx will be like this. And now as you can see on the numerator of this qx, that we can take out 2 common from here, isn't it? So when we take out 2 common, there will be x squared minus 3x minus 2 will be remaining. And that common taken out 2 and denominator 2 can be cancelled, so that our actual value of quotient qx will be x squared minus 3x minus 2. And as we said earlier, the value of remainder will be minus 13. So in this way, we can find out quotient qx and remainder r by using synthetic division method when the divisor is in the form of cx minus d. Now let's go to the fourth example, fourth divisor form. The divisor here is in the form of cx plus d. So as we have already discussed, that if the divisor dx is in the form of cx minus d, then it also has to be converted into standard form. So for that, first of all, here we'll take out 3 common. So once we take out 3 common, then inside the bracket there will be x plus 1 by 3. As we know that this has not been changed already in standard form because there is plus sign. So to make that minus into plus into minus, so let's use curly bracket 1 and x, and to change this plus into minus, we are going to write 1 minus outside and 1 minus inside with 1 by 3. So in this way, we can convert our divisor cx plus d form in the form of x minus a. So from here we can get the value of a as a minus 1 by 3. Alright, so we are clear about divisor part. Now let's look at the dividend polynomial part. Is there any unusual thing that you can see here? Of course, one x is missing, isn't it? X cube is there, x square is there, but x term is missing there. So due to that reason, we have to take that, or we have to put that term in dividend polynomial by writing with coefficient 0. So as we have discussed earlier also, so our polynomial px will be like this. Polynomial px will be 6x cubed minus 7x squared plus 0 into x plus 2. Actually, we'll do the same thing, whatever the value or whatever the variables is missing there with coefficient 0. And as we have already discussed the idea related with divisor dx, so same thing you can see here. In this way, the value of a will be minus 1 by 3. So now, when we use synthetic division method, first of all, we are going to put all the coefficient of polynomial px, and outside we are going to write minus 1 by 3. So first of all, we'll drop down 6. 6 will comes out, and let's multiply minus 1 by 3 and 6. So when we multiply minus 1 by 3 and 6, then 1 minus 1 by 3 and 6, so the value will be minus 2. That minus 2 will be written below minus 7. Now let's simplify minus 7 and minus 2. It will be minus 9, and minus 9 we have written down. So let's repeat the multiplication once again. Again, when minus 1 by 3 and minus 9 they are multiplied, the value will be simply 3, and that 3 we are going to write below 0. And let's simplify 0 and plus 3. It will be 0, it's 3 itself. Now finally, let's multiply again minus 1 by 3 with 3. The value will be minus 1, which we are going to write below 2. And when we simplify plus 2 and minus 1, it will be 1. So now, this time also, the value of remainder easily we can see here 1. But while we are writing quotient, let's be clear, isn't it? Because here, in case of dx, this time we have taken out 3 common. So this 3 should be used in quotient finding case. Yes, of course. In case of qx, directly from our synthetic division method, we can write 6 into x squared and minus 9 into x plus 3 will be written, and this 3, this common taken out 3 in dx case should be written here. That means should divide the things of quotient qx. So we know that if we have common, if we take out 3 common from the numerator of this part, from this qx, then there will be 3 common, and that 3 and 2 can be cancelled. So that our quotient qx will be eventually 2x squared minus 3x plus 1. So this will be our value of qx. So let's see here. So our qx is like this. So once we take out 3 common from the numerator, and that 3 and denominator 3 can be cancelled, the value of qx will be this, and the value of remainder will be 1. So in this way, we can find the quotient and remainder when the divisor dx is in the form of cx plus d. Now, let's see one more example. The last example, if the divisor is in the form of d minus cx. Actually, this is not a very new and difficult one. We know that if the divisor is in the form of d minus cx, first of all, we'll just simply rearrange them. Yes, so 1 minus 4x can be written as minus 4x plus 1. And when we take out minus 4 to make the coefficient of x as a 1, then there will be x, and minus plus would be minus, and 1 by 4. Now easily this can be compared with standard form, where comparing with that, the value of a will be 1 by 4. Yes, so we are going to do the same thing here. And as you can see in dividend polynomial, as none of the power of x is missing there, so no problem here. We are going to write simply px as it is in descending power of x, and dx we have already discussed, where the value of a will be 1 by 4. So now let's use synthetic division method. So let's write all the coefficient of x: 12, minus 11, 6, and 4. And outside we are going to write 1 by 4. So first of all, 12 is going to comes down. Now let's multiply 1 by 4 and 12. So when we multiply, we are going to get 3, and that 3 we are going to write below, yes, minus 11. So let's simplify minus 11 and plus 3. When we simplify this, we are going to get minus 8. Now let's multiply 1 by 4 and minus 8. When we multiply that, we are going to get minus 2. And that minus 2 we are going to write below 6. That's very good. Now let's multiply plus 6 and minus 2. When we simplify this, we are going to get 4, which we have written below minus 2. Now let's multiply finally 1 by 4 and 4. So when we multiply that, we are going to get one value, and that one we are going to write below the last constant of 4, and plus 4 plus 1, the value will be 5. So in this way, we have listed out all the coefficients that are going to be of qx, and similarly we have got the value of remainder. Now here also, we need to be very much careful about writing qx, because we have taken out minus 4 here common in case of dx, while it is changing it into standard form. So our qx, first of all, we are going to write simply the quotient as a 12. Yes, degree will be decreased by 1 power, then the dividend polynomial, 12x square minus 8x, and then plus 4. And as we had taken out minus 4 from the divisor, so that minus 4 will divide this numerator value. Now, for further simplification, if we have 4 common from the numerator, then the remaining value will be 3x squared minus 2x plus 1 will be there, and on the denominator there is minus 4 already, so that 4 and 4 can be cancelled, so minus will goes up and it will be simplified as a minus 3x squared plus 2x minus 1. So this will be the actual value of our quotient, whereas the remainder value will be simply 5. So the same thing can be seen here also. The value of remainder is 5. So in this way, we have discussed about 5 different forms of the divisor in case of synthetic division method. The first one is standard form itself, which is x minus a. The second form is x plus a. The third form is cx minus d. The fourth form is cx plus d. And the last form that we had discussed is d minus cx. So we have given here each example. We have discussed here example for each forms of divisor. So I hope you all are clear. Now I would like you to try out these 4 questions, which are similar with the examples that we have discussed earlier. I hope you all can do these questions easily by using synthetic division method. Thank you everyone. Thank you for being with us.